Hello. I wanted to talk about how I make some of my pen plotting art, and I wanted to talk about a specific project. So the idea here was if you imagine some kind of two-dimensional function, I wanted to be able to plot a kind of like a visualization of the function. So if you imagine like a set of 3D coordinates, and you've got like the X and Y, and then you have the function, it could look something like a some kind of wavy surface, you know. And yeah, this is kind of what I wanted to capture. You can get an idea, something like that. And I wanted to be able to basically plot an image that would look uh, something like this, but instead of it being like a continuous uh, form, I wanted it to be sort of pixelated. So at each kind of pair of coordinates in the XY, I'd have like an associated bar for the height. I'm kind of butchering this, but yeah. Um, so the first issue I came with in this project is I'm not working with 3D objects when I code. So I'm not, for example, I'm not actually in some sort of 3D physics or like a rendering engine, and I have these like uh, cuboids. What I'm actually doing is I have a canvas, and then I can draw on top of the canvas entities like maybe a square, maybe a circle, maybe a point, maybe a line, that sort of thing. So I needed to come up with a way to use this kind of 2D layering idea, but still kind of convey some element of like imply some level of like 3D-ness to the plot. So what I did was I essentially I started with a grid of points. So we're looking at these kinds of all these coordinates. So for example, this one here is point P, and it has coordinates x, y. Now associated to this point here, P, we can calculate some height, which we would call f of x. Now f of x could be anything. It could be some function which has inputs x and y. So for example, we could say like, I don't know, 10 times sine x plus y, for example. Now, how do we take this and make something 3D looking from it? Well, I started with a kind of parallelogram so that it gave the idea that we're looking from an angle. And then I subdivided this parallelogram into the same sort of thing, same kind of grid structure. And then each point in the grid would have an associated height depending on the coordinates and of course the function. And we could call this height z, maybe. What I then did is I had a function, so for this point P, so P is the x and y, and we now have this z, which is the height, which is just this. I could now write a function. So I could write a function that would take this x and y. It would draw a parallelogram that looked like this, and then another one that looked like this, and then a sort of diamond at the top. So you get this cuboid, sorry. Now, if z was negative, we would do the same, but we start with diamond, and then we'd have two parallelograms below. So this is an example of a plot I generated using the code I described earlier, and the f of x was a very sort of specific um, combination of like trigonometric functions. Played around with like the max function. So a max function would have two inputs and it would return the maximum of the two. So I just made some really kind of arbitrary combination of sine, cos, max, and applied some constants to multiply the x and y with, and it came out with this really nice, like isometric kind of perspective graph. And this is like an SVG export from the code, and then this will be mapped to the pen plotter, which I'm sure I'm probably going to show some clips of it plotting this now.
One thing I forgot to add into my explanation previously is in the drawing function I added a bit of code that would basically draw on the top of each cuboid a small hole to give this kind of really nice effect that all these cuboid sort of tubes are hollow. I think it worked out quite nicely, but you'll see in some of the instances the ink kind of bled through a bit.